Hello all, as promised, we are back with a new video. Today we are going to deal with Thevenin's theorem. So this is the one of the basic theorem in electronics. So let's start. So Thevenin's theorem states that any linear electrical network with voltage and current sources and resistance can be replaced at terminals AB by an equivalent voltage source V Thevenin in series with an equivalent resistance R Thevenin. So let's see what does this mean. See, you can see here this circuit consists of two voltage sources. One is of 20 volts and another one is of 10 volts. It's in opposite polarity. And you can see there are three resistance here: 3 ohm, 6 ohm, and 3 ohm. So this is the terminal A, and this is the minus sign. This is terminal B. So this is the bit of complex circuit. We need just one voltage source and one resistance. So that is the Thevenin's equivalent. This is the complex circuit. Thevenin's theorem will help us to simplify this circuit into just a voltage source in series resistance with the equivalent resistance called Thevenin's resistance. So you can see here many voltage sources can be replaced at terminal AB by an equivalent voltage source in series with equivalent resistance. So let's see how to solve this. See, here left side we have 20 volt source and here we have 10. So just define a current I. So using KVL, trace back from this 10 volt, you can see minus 10 plus 9I, that is plus 6I plus 3I, 9I minus 20 is equal to 0. So you can get I equal to 30 by 9 ampere. So this is, we need to find VThevenin for these terminals A and B. I am not mentioning it as A and B, but this is the terminals A and B. So you can see VThevenin over here. Since this is an open circuit, no current flows through this 3 ohms. So using KVL equation here, that is VThevenin minus 6I plus 10 equals 0. So you can see VThevenin is equal to 10. This is how we find the Thevenin's voltage of this whole circuit. It means these two voltage source can be replaced by just 10 volt. So now let's see about the resistance part. In order to find R Thevenin of the circuit, if we have voltage sources in the circuit, we need to short it. If we have current source, we need to open it. Since in the circuit we have just two voltage source, make it as short circuit. This is short, this is short. Then we get 6 ohm in parallel with 3 ohm. This is into 3 upon 6 plus 3, 2 ohms. This 2 ohms is in series with this 3 ohms. So R Thevenin is 5 ohms. So according to Thevenin's theorem, this whole of the circuit consisting of 2 voltage source and 3 resistance can be replaced just by 1 voltage source in series with series resistance. This is called Thevenin voltage and this is called Thevenin's resistance. You see 10 volt is V Thevenin, 5 is R Thevenin. So next we'll see about a circuit. Here we have just a dependent source. See, you can see here this 20I1 is a voltage source which is a dependent source. It depends on the current I1 which is flowing through 30 ohm. So the problem is find R Thevenin of this circuit. See, just we have a dependent source and there are no independent sources. So it becomes extremely tough to find R Thevenin of this circuit. In order to approach this circuit, how to solve R Thevenin for the circuit, we need to introduce a dependent source that is called test source. So again, here is A and B terminal. I will start again. So let's see how to solve this one. See, we have introduced 1 volt. This is the test source, and this is the I test, and this is what V voltage. So R Thevenin will be V test upon I test because this is the terminal A and B. we need to find Thevenin's resistance across this terminal. So this is the KVL. You can see V minus 20I1 upon 10 plus V upon, this is 30, V by 30 plus V minus 1 upon 5 is equal to 0, and I1 is equal to V by 30. So substituting the value of I1 here, we get V is equal to 6.8 volts. 6 by 8. This is 6 by 8. So I test can be found out by this. 6 by 8 minus 1 upon 5. We'll get minus 50 ampere. Ignore the minus sign. It just means we have taken the direction of the current which we chose is in the opposite path. This current flows from 1 volt to V volts. So R Thevenin will be 1 volt upon 50 milliampere. This is 20 ohms. So we need to introduce voltage source as test source or current source depending upon the situation. Here we have 5 ohm. So we need to introduce voltage source such that we get current. We are just short circuit here, that is just a line. Then we can introduce current source. Okay. So this is the assignment. You can see here. It also consists just of a dependent source. 0.1 V1 is the current source. It is dependent on the voltage across the 100 ohm. So try to solve this one. If you don't get it, just ping me in my blog hobbyproject.blogspot.in or subscribe for more videos. Thank you.